Good afternoon, everyone. Today I'm going to present you about the nuclear reaction simulator. Here's my group member. This is the number. Part 1. Yep, your turn, Mickey.
Okay, so part 1 is nuclear reaction. What is a nuclear reaction? It is a process that involves the transformation of atomic nuclei resulting in the change of one or more nuclides. And nuclear reactions can be initiated by bombarding a nucleus with another particle, such as protons or neutrons, or it can be initiated by the spontaneous decay too. There are two types of nuclear reaction. There is nuclear fusion and nuclear fission. And nuclear reactions release a tremendous amount of energy. Nuclear fission is it means that the nucleus of an atom splits into two or more like smaller nuclei, releasing some energy. And the fusion is just like the inverse of the nuclear fission. It's like two atomic nuclei that combine into a one larger nucleus, releasing a significant amount of energy too.
Next is a part 2 of this nuclear reactor, which is the basic component. Well, first is a reactor core. Reactor core basically is a place where nuclear fission happens by the thousands of uranium fuel piled in the metal tube. So the uranium is a fuel that powers the pressurized water reactor. Next is a control rod. Very simple. As the name said, it's a rod that controls the reactions of the nuclear reactor, containing a material such as hafnium, boron. Yeah. We're just introducing. It's in the last of the slide. Okay. Lastly, is a pressure vessel. Well, pressure vessel is a large cylinder steel vessel containing a core, cooling water, and generated atom that require high reliability to withstand high temperature, high pressure, etc.
Okay, next is the coolant. Like its name, it is water that is pumped to the reactor core and then around the nuclear reactor in order to slow down the neutron in the reactor core, which make the fission reaction more effective. And it absorbs the heat produced in the reactor core and carry it to a different part of the reactor. Next is the coolant pump. It have a function to move the coolant different to go around the circuit, which run between the reactor core and the steam generators. Like I have said that the coolant have absorbed the heat, so it has a chance that the coolant temperature will get higher and higher. And when it become very hot and reach to about 325, but we don't want it to boil and turn to steam, so we have the pressurizer to cool down the coolant and for it to stay liquid. That's what they call a pressurizer water reactor.
I'm sorry. So the next part is the steam generator. In the steam generator is like the hot coolant runs through the tube surrounding by another circuit of water. So basically, it just make the water into like a hot tube and turn into steam like a kettle to make a steam, as the name suggests. So the next one is the generator. Inside generator, spinning turbine is turned into electricity turbine magnet inside coil. This part is kind of like we call it dynamo. Its type current is AC and its sleep the electricity leaves the generator when they supply across the country. Yeah. So the next part is the condenser. It is a after the turbine, the steam is cooled and condensed back to water to throw back into the steam generator and turn into electricity again and again. The water is reusable and yeah, that's it.
Next one is to the turbine. The streams comes out of the steam generators and flow to the turbine, making them turn. This is like a wind turbine, only at a much higher speed than the normal one that you can see in the daily life.
Next up, let's talk experiment. In the experiment, the goal is to generate enough energy for the nation for one day. The pressurized water reactor makes electricity by producing steam, which drives the turbine. Unlike burning fossil fuels, nuclear fission releases absolutely no carbon dioxide or any other greenhouse gases, so there isn't any problem to the environment. Now, how we do the online experiment is use the control panel to operate the reactor. First, you must switch on the coolant pumps when the coolant has reached to 90 Celsius. Next is to start the engine to uh, generating heat. Leave the control rod slightly, just 10% or less to begin with. For safety, if the reactor gets too hot, it will automatically shut down. And lastly, we increase the steam output from the steam generators to turn the turbines and produce electricity. The power demand will change at different times of the day. So we have to match our input for each period.
เล่นเกมเชิญไปเล่นได้เลยครับนี่ครับมาเชสเตอร์ออกมาหาอะไรมาเชสเตอร์
โอ้เดี๋ยวเลยเอาเลยอินเตอร์อยู่นี่คุณเล่นเนี่ย
มึงบรรยายให้กูเล่นอาจารย์ลำลุงมีเพลงได้มึง
ให้ค่าความพยายามหาอันนี้มาเลยนะดิ
Welcome to the university.
เลย Let's go
ไม่เอาอะไรเลยอ่ะ
Turn on the clock on first
on switch
Yes มึงไม่พากเว้ยมึงพากดิมึงพากหน่อย
Raise the control.
Raise to the green bar คือเลื่อนไม่ได้
And start producing electricity.
เกิน
Morning.
เราจะตายกันหมดเราตายกันหมดแล้ว
สนุกดีเท่านี้
Yes
The power is overload ตูมWe normally have to use the mouse or the keyboard to play, but it doesn't have, so it's a little bit difficult to control.
Can we have the mouse
Yeah.
in order to control
Yes. If you have one, that would be great.
my one?
Raise the steam output to turn the turbines and start producing electricity.
เฮ้ย เริ่มใหม่ เมาส์มาละ
ปิดไม่ได้
Morning. Energy
ปิดไม่ได้
เมาส์มาละ
กดปิดไม่ได้กดปิดไม่ได้
มึงมาเริ่มใหม่ กูมีเมาส์ละ
แค่แค่ซับกูนั่นน่ะโบไม่ยอมคนนี้ไม่ยอม
กูจะไม่เสียหน้า เอ้า ไม่โหลด เว็บลมแป๊บ
เขาไม่อยากให้เราชนะหรอดูท่าแล้ว
เฮ้ยกูไม่ยอม อันนี้กูภูมิใจมากทำไมไม่ขึ้นอ่ะลองออกรีสตาร์ทเกมเอาแล้วเข้ามาเป็นแมนเชสเตอร์กูเลยหยิบไปเลยนะเว้ยนี่เป็นมันไม่โหลดเหรอปกติมันจะไม่มีปัญหาเขาอาจารย์แต่มันจะมีปัญหาอีกทีก็มีปัญหาเนี่ยจะมีปัญหาตอนจะทำเราต้องเร็วๆด้วยนะเพราะเพื่อนเขาต้องมีเซนด้วยครับมึงเล่นในมือเขาดูไหมมึงเล่นในมือถือก็ได้ไอ้พวกเล่นเดี๋ยวเล่นให้การดูดีกว่าใช่ต้องเล่นให้การดูนะถ้าอันนี้มันไม่ติดอันนี้คือมีเลือกออกไปหน้าจอได้ครับผมมีนี่ไงถ้าCPUมันไม่แรงก็เอาแล้วก็เปิดแล้วก็เปิดเลยใช่ไอซีทำไมกูได้คะแนน-1ไอซีกูนี่กูไม่มีเน็ตแป๊บ
โตสิกนอลหนักกว่าเดิมอีกไม่มันจะไม่เสื่อมแล้ว
ทำไมไม่ได้วะ
ดิงดิ
พังทุกอย่างทำไมมันพังทุกอย่างจริงๆวะเนี่ยมันไม่ขึ้นวะทำไมไม่ได้วะ HDMI เดินได้ปะ
HDMI มีอ่ะ
โง่ๆเลยมี
ตรงไปเลย
อ๋อมาแล้ว
ต่อไปไม่ต้องมาเจอใน CPU ของเครื่องนะครับ CPU มันไม่ดีต้องไม่แล้วนะคุณเอาเครื่องคุณนะแล้วก็เตรียมต่อออกฟรีครับออกจอใหญ่ครับไม่ใช่มาใช้ CPU นี่นะ
มาเริ่มเล่นเลยเปิดปึ๊บ
อันนี้คือต้องทำให้มันอยู่ในสีเขียวป่ะ
ใช่เราต้องให้มัน stable ไปเรื่อยๆอันนี้ก็จะขยับเราต้องขยับตามเริ่มแล้วอ้าวแม่งออก
ไม่พังวะเนี่ย
ไม่พังจำนะ
เล่นอยู่เลย
กูเล่นทั้งวันนะเมื่อวานแม่งไม่ล่มเลยนะ
เว็บจากแมนเชสเตอร์แล้วแมนคุณภาพไม่ดีผมตัดคะแนนไปนะหรือว่าไม่ทดลองมา
ผมลองทั้งวันแล้วครับ
ต้องลองมันได้ใช่ไหม
ตอนเราลองมันได้กูเล่นประมาณ3 วันอ่ะตอนนั้น
โดนหักหน้าเสียเวลาครับเพื่อนด้วยครับ
โอ้มึงล้อกูเล่นกูไม่รู้เนี่ยได้ละกูเชื่อว่ามันได้เน็ตกูเนี่ย
มันเป็นเน็ต
มาละ
แล้วกดพีเอล
ไม่มันใช้เมาส์เลื่อนได้นะครับเราต้องเอาให้มันตรง power demand ครับผมสีฟ้าต้องเท่ากับสีแดงครับผมข้างบนครับต้องเท่ากันไปเรื่อยๆครับเอ้ยตรงเนี่ยครับนั่นในกลางก็จะแบบเส้นเท่ากันนะครับผม
ให้มันแบบขนาดคุณทำเป็นคุณก็ไปทำงานมันได้เลย
นะครับผม
มันต้องอยู่นานขนาดไหน
จนกว่าจะจบวันนึง day 1เสร็จปุ๊บเขาจะบอกคะแนนเราเขาบอกว่าเราได้คะแนนเท่าไหร่มันจะดูว่าแบบถ้าหากว่าดีแมนมันเปลี่ยนก็จะเปลี่ยนเนี่ยกราฟมันเริ่มสูงละ โอเคไม่มากไอ้สัสโอเคขึ้นแล้วเราก็ต้องปรับ steam generator ขึ้นตามก็รู้แล้วปรับอยู่ไหวชิวได้อยู่ตีสามแล้วตีสามบ่ายสามไม่ต้องไม่ทำยังไงได้ไม่ให้ไอ้แรนเติมโตลงแต่ว่าไม่ร้อนเกินอันเนี้ยกราฟเท่ากันละใช่มันทับไปแล้วนะทับได้มันให้ใกล้กันมากที่สุดอะขึ้นนะได้4 ทุ่มแล้วไอ้1 นาทีเอาละกลุ่มต่อไปเสร็จแล้วพลังน้อยไปต้องอัดเรีแอคเตอร์คอต้องให้โมชิชั่นของไอรอดมันแม่งลงมาต้องถึงกี่โมงเดี๋ยวมันก็ประมาณวันหนึ่งอ่ะมันเกินที่คืนแล้วยังไม่จบวันยังไม่12อ่ะใช่เราเริ่มตอนไหนจำไม่ได้แล้วแต่มันก็ใกล้ละคุณไม่ต้องมีเซนนะคุณมาเริ่มเล่นอันนี้ให้ดูเลยตอนนี้เราเล่นการทดลองนะครับมีมาในตัวดาวรับทราบรถแรกเราสตรีมเจเนเรเตอร์ป่ะใช่เนี่ยกำลังกดรถอยู่เนี่ยค่อยๆกดตามจำลองการทำงานโรงไฟฟ้านิวเคลียร์ด้วยการแล้วอีก6 ชั่วโมงการแล้วอยากได้ขอบคุณครับใครใช้โปรแกรมอะไรนะให้เอาคอมพิวเตอร์นึกว่าจะล่วงแล้วมึงรถจิ๊บจะระเบิดใส่หน้ามันจะใช้ทับกับหัวจะใช้กับหัวไม่
ใครพูดคนแรก
โอ้มันต้อง
กัด
รีวิวของไม่แล้วเดี๋ยวคุณจะแบบเสียเวลาครับต่อไปขอดูได้คอมเมนต์นะ
อะไร
ไม่เป็นคาแรคเตอร์กูพรุ่งนี้มีทักด้วยเอาเลยพูดภาษาอังกฤษของพ่อเล่นแล้วเพิ่งตื่นจากก็ยังตก
เร็ว
Okay, hello. So today we'll be doing this simulation and a physics presentation on beta decay. All right. So these are our members. We have Wish, me, Korn, Dan, and Ian. And then all 2 more. They also have Jimmy and Kana. All right, so first of all, let's just get right into what even is beta decay. Well, for the introduction, beta decay is a radioactive decay that transforms an unstable atom into a stable one. Okay, so this is our PET simulation. So, yeah, just 1 second. Let us set it up real quick. Lua. Alright. Alright, so this is the simulation. Alright, 1 second, let the thing load for a little bit.
As a tutorial, please don't rely on the computer because the CPU is not so strong. You may use your iPad or your computer.
Okay, alright, here we go. So first, let's talk about the single atom for a second here. So as you can see, this is a tritium atom, which has a atomic mass of 3. So as you can see, it starts off as a hydrogen with 2 neutrons and 1 proton. This is not a stable nucleus yet. So once we hit start and the half-life starts going, you can see that the atoms become stable at around the half-life mark. This is not for all atoms, but this is just the probability of it becoming stable. As you can see, what happens is that the 1 neutron actually turns into a proton, and the atomic this is actually called the beta minus decay, which occurs when number increases from 1 to 2. Alright, but if we go back for a little bit, you can see that if we stop at the right moment, there you go. You can see that when the atom becomes stable, it actually releases 2 things, which is electron and antineutrino. In this case, there's actually 3 types of decay, which is alpha, beta, and gamma. And generally, alpha and beta decays are the one that releases these kind of things, but the gamma decay does not. All right. And once it's done, it becomes helium instead of hydrogen.
All right. Hello. All right. So if we look at the time frame for this, we can see that the half-life of this atom tritium is about 12.3 years. And as you can see here, if I go ahead and hit the reset nucleus, okay, yeah, we and if I keep hitting the reset nucleus, we see that sometimes the nucleus decay faster and longer, depend on the probabilities. But yeah, the half-life is around the 12.3 years. So if here I change the element to carbon 14, so after I switch the atom to carbon 14, this is the unstable version of carbon. So I'm going to go ahead and reset my nucleus again. The carbon 14 has 6 protons, or versions of carbons have six protons, and it has 8 neutrons. So the 6 protons plus the 8 neutrons give the mass of 14. Now, during the decay process, you can see that it's going to occur like what happened with tritium. So when the atom decays, and we need to wait for it to decay, or right there, it just decay. I just keep hitting the reset nucleus. We can see that the same things occur like the tritiums that have been demonstrated before. So yeah, let's move on to the multiple atoms.
Right. Next up, in the regards of multiple atoms, so this will eventually turns into an applied mathematics probability thing. So first of all, let me select carbon 14 for this case and add all of the 98 or 100. Let me see again. Just let me add all of them and reset. We'd see here that there are a total of 50 atoms here, which are all carbon 14. So yes, no, it's 100 or 99. So what we see here is that the half-life fine right here is at a little bit above 5,000. That is because the half-life of carbon 14 is at roughly 5,730 plus or minus 40 years. And for the next part regarding the statistics and how fall off or half life overall, I'm going to let my friend explain it.
Right, so as you can see here, what the fuck? Now, as C14 start to decompose, you can see that um, electrons and antineutrinos are emitted. And as you can see from the graph here, the number of C14 starts to drop. And so until the number of C14 and N14 becomes equal, which is around this line. The half-life, yeah.
All right, for the next part, we can see that the carbon start out with 99, and now the carbon 14 goes down to around 54, which is the half life point, and we can press continue to about 10,000 years, and then we will pause. And in this process, the carbon 14 goes through the radioactive decay, with it decreasing, and the nitrogen atoms is increasing. And at about this point, we're going to be left with around 26 carbon and 73 nitrogen atoms.
Okay, hello, I'm smart number 12. Now, after we looked at it after one half life and two half life, we can. It is predictable that if we allow this beginning at 200, it will cut to half, which is 100, and then half again, which is 50. Allowing to run more will around that there, which is its third half life, will be. It should have around 225 atoms. So generally, you can use a formula to predict the amount of atoms, which will be n t equal to n0 to okay to the t over t 1 over 2, which this would allow us to predict the amount of atom that will be left after some amount of time with respect to its half-life.
So that should be reduced to about 50. I think there was 48, right? But it was reduced to about one half, and at 12,000 years we are at two half lives, which means that we will be reducing to about one quarter or one fourth of the original amount, half of another half. So by that point, we should be down to about 25 atoms of carbon 14, and at three halves, we should be at around one half of one half of one half. So at one half, we should be at one half of the original amount. Two half life, we should be one half of one half. So that's one quarter. And at three half life, you should be one half and one half of one half. So that's around 1/8 of the starting amount. So half of half, one fourth, and then 1/8. And then we can see that, once again, the amount from what we had here at two half lives has been cut in half. We have only 13 remaining atoms of carbon 14, which are like an unstable nucleus. Thank you very much.
เรียนจับไมค์อันนี้นะครับอย่ากดมิวนะกลุ่ม2อย่าไปกดไม่ใช่คุณกดอะไรแน่นๆนะมันคุณไปดับเสียงของเขาครับเสียงมันไม่เข้าครับเนี่ยผมถึงต้องเอา2 กล้องเนี่ยป้องกันพลาดเนี่ยคุณทำดูดวงให้ดีที่สุดคุณเด็กปกเสื้อครับเดี๋ยวอย่าไปทำนะห้องหน้าวันนี้ใช้เป็นสูงแน่เลยนะ
แป๊บนึงแป๊บนึงไอ้ใครยังไม่พรีเซนต์บ้างมาดิเกี่ยวคนมีกี่คนไม่มีเลยนี่คือกลุ่มสดเลยกลุ่มสดเลยเว้ยกลุ่มสดเลยคันนี้วะอะไรกลุ่มใหม่เลยเนี่ยไอ้เหี้ยเกี่ยวกับไอ้เนี่ยสร้างอะตอมอ่ะได้จากนี้เลยก็ได้ก็เนี่ยมีแค่นี้เลยเว้ยไม่แค่นี้เลยการทดลองก็คือให้ดูนะว่าแบบแค่3ตัวนี้มึงสามารถสร้างในทางนี้เลยเอาเหรอมีใครอีกไหมหมดแล้วไหมหมดแล้วแค่นี้เลยห้องข้างในที่ไม่มาโอ้โหไม่มาแล้วสูตรถ้าโผล่ได้ปะทำเหมือนในการรอบที่แล้วที่มันไม่มาเริ่มเลยดูก่อนนะเปิดมาฮัลโหลเทสจะเริ่มเลยไหมโอเคhello everyone todayรอบหนึ่งกันเริ่มเลยนะโอเคgood afternoon everyone today we're going to talk about atom especially these three so atom as we know it is the building block of all matter and chemistry atom can combine with other atoms to form molecule but cannot be divided into smaller parts by ordinary chemical process now most of the atom is an empty space the rest consists of the 3 basic size of subatomic particles protons neutrons and electrons the proton and neutron form the atom's central nucleus the ordinary hydrogen atom in this illustration for example now we have an hydrogen atom as the name suggests protons have a positive electrical charge while neutrons are electrically neutral they carry no charge overall then the nucleus has a positive charge circling the nucleus is cloud of electrons which are negatively charged like the opposite of magnet that attract one another the negative electrons are attracted to a positive force which bind them to the nucleus. The nucleus is small and dense compared with the electron, which are the light charged particles in nature. These electrons encircle with the nucleus in orbital paths called shells, each of which holds only a certain number of electrons.
ให้เขาเสียบให้แล้วกันให้เขาเสียบให้ได้ก็อธิบาย element so what we have here is the elementary table so it consists of a lot of elements which have different numbers of protons neutrons and electrons and the benefit from this is when we put neutron and proton here it changes so the benefit from this is we can visualize each of these elements will look like and how much it will weigh, how much electron is in it, how much ion there is, and yeah, and that is I think it is a very important for you to understand about chemicals in general and atomic physics if you want to learn about quarks or quantum charges later. Yeah, ต่อ
So basically, what we see now is helium, and the thing that determines that it's helium, it's its proton. As you see here, there are 2 protons here, and it determines as a helium. But if we add a proton into it, and it changed to lithium. So basically, proton determines what kind of element it is. And moving on, this one is the orbit model, but let's have a look at the cloud model. So as we see, there are 3 protons and 2 neutrons here, and this one is defined as lithium. But if we add electrons here, the orbit cloud became wider and wider, and we see now we see it as a negative ion. But if we change this one to beryllium, and we added neutrons into the same amount of protons,
I think something might be missing in this group because you didn't talk about whether an isotope is stable or not. This is an unstable isotope due to, but that is an option there. You can choose. This is an unstable isotope.
okay, so for example, if we add it here, and if we are trying to add neutrons, and we can use this box to check whether it's stable or unstable. So let's have a check. This one is unstable. Because the number of protons and neutrons are different, and the electrons is not neutral. So if the number is not the same, then it's not stable. So this one, as you see, the number of protons, neutrons, and electrons are literally the same. So we can define it as a stable one. But if we change it a bit, adding protons into it, adding electrons into it, and it became unstable. So this is how we define unstable and unstable isotopes.
Now for easier demonstration, we'll change to orbit. Tino.
Right. So they already talk about. Thank you. So they already talk about the more complicated things. I'm gonna explain more about on this side. So first, I want to say that if the element is higher in the group 6, right? Group 6, they will actually prefer to take in more electrons to fill in the shell, because the shell maximum is 8, number is 8, so they would prefer to take in 2 more than to give away 6. And to explain this net charge, so basically this one here, if I put in protons or electrons, this one basically will, we get protons or electrons, the one that has more minus by the one that has lower number, and we will get the net charge. This is basically, that one's done. And if you look at the mass number, if you add in the electrons, the mass number doesn't really change. That signifies that the electron doesn't really have that much mass. However, if you look at the proton, that one adds the mass number by 1, and that same goes for the neutrons as well.
Okay, so here I'll be explaining more on the types of models of the atom. So, for example, a stable hydrogen atom has 1 proton, 1 neutron, and 1 electron. In this one is the orbits model. But if we see as a cloud, it says the probability of an electron appearing in this circle right here, and the as a circle around the atom. So for the orbits model, its history is very long, but the first one to have the shape of this orbit atom, I believe, was Rutherford. So when he shot the alpha particles through a gold leaf, he found out that not only does the atom has positive and negative charge, but it has a solid nucleus with electrons surrounding them. Since the alpha particles got redirected by the electrons, but completely reflected by the nucleus, which contains protons and neutrons. However, in more recent years, with the discovery of quantum mechanics, they talk a lot more about probability and things like that. So that is why if we add more electrons, the circle become bigger, since there's more probability of finding electron in this area, that, rather than not having less electrons.
Okay, so what about the element? So the element profoundly affect the property and behavior of atom. The number of protons in an atom nucleus define its element and largely determine its chemical property. Elements are arranged on the periodic table based on increasing atomic number, which correspond to the number of protons. The arrangement of electrons in an atom energy level or shell is influenced by the element. This electron configuration dictates how an atom interacts with chemically and determining its reactivity and bonding tendency. Different elements exhibit unique characteristics due to variation in atomic structure, such as the number of protons, neutrons, and electrons. This structural difference leads to the diverse physical and chemical property among elements and contribute to the rich diversity of substance in the universe. Okay. Okay. กดไม่ได้นะยังไงนะตอนนี้อันนี้คือสองอะไรไม่รู้เลย อันนี้คืออะไร
So basically, for example, number 3 here, it means that the proton, it's the addition of proton and neutrons in the middle, and the number 1 here, if we add it with this, then it defines the number of protons that are within the atom, and the number 1 constant. If we change it, there are 2 protons, 2 neutrons, and there is just only 1 electrons, which is not stable. So if we add electrons here, then it becomes stable. The number 0, it means that there are 0 charge and the atom is stable. So if we added, for example, if I added a lot of protons here, so this one, the number, as I said before, it means that the number of proton in that is in the atom, and the number of proton defines the name of it. For example, this one is boron, and if I added neutrons to the same number of protons, then the number here became 10. So, for example, if you wanted to know the number of neutrons, we use this number to subtract by this number. So we would know the number of neutrons. For example, 11 minus 5, it's equal to 6, and there are 6 available neutrons here. And moreover, if there are if there are more electrons than protons, we use the number of protons to and subtract by the number of electrons, then we get this number. For here, we use the number of protons 5 and subtract it by 7 electrons, then we'll get the number -2, and this is how the symbol are formed.
อันนี้สำหรับอีก1 คนนะครับผมที่ไม่ได้มาวันนี้กูก็ไม่รู้จะทำยังไงให้มันเสียงได้ยินดีก็เนี่ยฮัลโหลอันนี้ได้ยินปะพูดหน่อยได้ยินปะพูดหน่อยฮัลโหลได้ยินปะได้ยินอธิบายมีเสียงกันหน่อยนะเริ่มเลยปะอาจารย์จะไม่ได้ยินเลยดิประเด็นกลัวไปใกล้ๆอาจารย์หน่อยแล้วกันไม่อยู่นี่อาจารย์แต่คือก็ได้แค่นี้ไม่จ่อให้เขา
ลองพูดหน่อยเปิดมาชัดดีแล้ว
อัมงอกต้องดูอะไร
So a standard atom has a big charge of 0, or in other words, it has an equal number of protons and electrons. The positive protons cancel out the negative electrons. When the number of electrons does not equal the number of protons, the atom is stabilized. And the unstable atoms have excess internal energies, with the result that nucleus and undergoes a
ไอ้โน้เสียงหายอันนี้เข้าหูฟังกูรอ
ไหนอ่ะ
stabilized and unstable atom.
พูดหน่อยพูดใหม่ได้ไหมเมื่อกี้พูดใหม่
ตั้งแต่ตรงไหนอ่ะ
ตั้งแต่ตรงประมาณ10 วิที่แล้ว20 วิที่แล้ว
Okay. An unstable atom has excess internal energy, with the result that the nucleus can undergo a spontaneous charge toward the more stable form. This is called a radioactive decay. And lastly, how can we turn a stabilized and unstable atom? Stabilizing an unstable element typically involves changing the atomic structures to make it more stable. This can be done through process such as a nuclear transmutations, where the unstable nucleus of an atom is charged into different, more stable nucleus through radioactive decays or particle bombardment.
โอเคได้แล้วไม่ไม่ได้หมดเว้ยคือเด็กมันเด้งเว้ยไอ้แม็กมันไม่ไหวแล้วเว้ยไม่ไหวแล้วแค่นี้ก็
ล่าม
ประมาณนี้แหละครับประมาณนี้อาจารย์
ประมาณนี้
ไม่เราเอาคนอื่นเนี่ยผมไม่เนี่ยจริงเหรอคนเวลาคุณทำอะไรอาจารย์จำผมไม่ได้ผมไปเรียนอาจารย์จำได้คนเดียวที่จะคิดได้เดี๋ยวห้องไปที่ห้อง4ใครจะมาพูดเราเดี๋ยวย้ายไปห้องคุณนะเดี๋ยวส่งกันเองครับพวกห้องหน้าครับคุณพูดคุณโสดเลยนะกลับนะวันนี้นะคะแนนเด็กเป็นศูนย์เลยนะครับห้อง4ใครจะมาพูดว่าห้อง4ให้หมดกันดีพูดยาวพูดก่อนครับใช้เวลาก็ไม่รู้ว่าใครจะใช้เวลา6 นาทีหรืออะไรแล้ว15 นาทีโอ้ใช้แล้วกันเดียวงั้นก็โยนชายงานเริ่มเลยครับแม่โต
ไม่อย่าจับนะครับเพราะว่าคุณจับแล้วคุณไปกดปุ่มนิ้วแล้วเสียงมันก็ไม่เข้านะครับเอาเสียบปกเสื้อเอานะครับมีปกเสื้อเอานะครับปกเสื้อนะครับเอาไม้มีปกเสื้อครับแล้วก็ถือนี้ผมใส่ปากครับ
ไม่ได้ดูแล้วว่าฮะพวกกลับมาแล้วโทษ
คนไหนพูดก่อนมีไปนะคนไหนพูดก่อนมีไป
ผมมีไมค์แล้วครับ
มีไปแล้วก็อันนี้จ่อปากให้ด้วยนะผม
อันนี้คือมันมิ้วอยู่หรือเปล่าครับ
ใช่ครับไม่มิ้วมันเปิดรับเสียงอยู่ตอนนี้ครับคุณนี่กระเป๋าเสื้อหรือปกเสื้ออะไรก็ได้ที่ไม่ขัดไว้ครับเดี๋ยวแล้วอันนี้จ่อปากให้ผมด้วยนะฟังเสร็จมี2 อันนะครับ3 อันอ่ะ
เราต้องมี3 อัน
คุณก็เอานี่ไปดิอันนี้มีไหมคือมันมีกี่คนกันแน่ที่มีสกิป
3 คน3ที่ใช่แค่3มึงขาด3พร้อมยังไม่เดี๋ยวมึงก็ไปฝั่งนู้นต่ออันนี้ก็มึงก่อนใช่เปล่ากูแตกเอาเซิร์ฟเวอร์ได้ปะOkay, so let's start then. Today we are going to be presenting an experiment on nuclear fission. But first of all, I'll be the one explaining what nuclear fission is, or at least how do we comprehend it. So, เลขที่1ครับผม from 604นะครับ Okay ครับ So imagine yourself cracking a peanut. The shell bursts open, releasing energy and smaller pieces. Now, nuclear fission is essentially similar, but on an atomic level. So essentially, it's a process where a heavy atom nucleus, like uranium, gets split into smaller nuclei by a neutron, and the split itself releases a massive amount of energy in the form of heat and radiation. ไม่ทับตัวทับครับอะไร
โอเคเลขที่4นะครับเลขที่4นะครับso we're going to talk about some terms that we may need to know in order to understand about nuclear fission. The first one is a neutron trigger, which is a neutron that hits heavy atom like uranium in our example that we're going to show. Another thing is splitting act. เดี๋ยวเล่นต่อครับ which is that the uranium nucleus can handle the impact and split into 2 smaller nuclei, which is called a fission product. The other one is energy burst, which is that the splitting itself releases a huge amount of energy, such as heat or radiation from the heat.
Oh my god.
Speak whenever you want.
But that's not the end. You see, more neutrons are also released during the split, and as we know, the neutron starts the reaction. These neutrons can go on to hit other heavy atoms, causing them to split too, causing a chain reaction that releases even more energy. This chain reaction is what powers nuclear power, and also what makes it such a devastating force in nuclear bombs. However, controlling the chain reaction is crucial in power plants to prevent meltdowns, and in the bombs, the goal of the uncontrolled release of energy is what causes the explosion.
ต้องถืออะไรบ้างไหมต่อไหม
เดี๋ยวพูดเลย
Hello. I am number 8 from 604. So the last person was number 12. I am number 8. So next I'm gonna go briefly talk about the components and equipment in this experiment. So the gray dots are representing neutron, and the red dots represent proton. We also have the uranium-235, which is quite unstable, which is very unstable, and when we shoot the neutron to 235, we will see these daughter nuclei. And we also have this gun, our imaginary gun that shoots a neutron to the uranium-235, and you can see how the potential energy and total energy changes. Let's go.
ไม่เดี๋ยว
Let's go.
Hello, my name is Anuditev Ali, number 15, class 604. So now we're going to see what happens when you actually fire the neutron at uranium-235. So as you can see, immediately the potential energy increases to a breaking point where fission happens. And that's when uranium-235, which as my friend said, is already a quite unstable substance, reaches its breaking point and achieves fission, therefore turning into uranium-236, which is even more unstable and basically explodes. It then, sorry? Shoot at neutron. Also, you can see that as fission happens, there are several things happening. For example, there appears to be daughter nuclei splitting from uranium-235 when it becomes uranium-236. There are also basically neutrons or particles that flies out of them as well, which you'll see later how that affects the chain reaction.
Please stop. Let's go. Okay, so I'm number 6 from 604. Next I'm going to talk about the chain reaction. So let's start with a single uranium-235, right? What you see when you fire a neutron into it, it fires daughter nuclei and more neutrons into random directions. How about we increase it a little? Let's say about 19 of them. So let's see what happens. You see, as the neutrons fires off in random directions, it hits other uranium-235, which creates a chain reaction of fission that would make it also become uranium-236 and explode. So let's say we have like 100 of these, just like the real nuclear fission thing to produce energy. Let's say we have all of this, right? So there's a lot higher chance that of this uranium-235 will be affected by a neutron. So, yep. Now let's talk about what's actually happening in a nuclear reactor, right? So as I said before, just like the chain reaction, when we fire the neutron in here, boom, it creates a chain reaction. So it randomly fires all the neutrons into random directions, which would produce energy, just like that. So it requires a little bit of luck to say where the neutrons land, but eventually, as we go, as you can see, we will produce a lot of energy as we fire the neutron into the uranium. And eventually this will be depleted and we will need to replace a new core. So thank you very much for listening to our presentation. Goodbye.
Thank you. Điều trái về không luôn liền. Đây. ลูกดีบ้า
ไปหาอะไรกัน
เดี๋ยวเขาว่าโอเคเชื่อของผมก็มีเดี๋ยวแกะมาให้เขาปั้นขออนุญาตถามนิดนึงครับเดี๋ยวผมขอเช็คชื่อก่อนคุณอย่าเพิ่งไปเซ็นหรือคุณจะเช็คให้ผมเดี๋ยวผมลองเช็คชื่อนะครับได้อนาคตจะเป็นครูอยู่แล้วนี่ครับอนาคตจะเป็นคนสอนหนังสือแล้วเดี๋ยวต้อง ต้องเครื่องหรือว่าเครื่องคุณก็ได้
ไอ้ดอกมาให้ผมก็ได้ครับ
ให้มันอยู่ในไลน์กลุ่มคุณเปิดในนั่นเลยเปิดใน Google Note แล้วก็ติ๊กให้ผมเลยครับแล้วก็อัปโหลดขึ้นไปนะอัปโหลดขึ้นไปในไลน์กลุ่มเรานะครับมีเพลงได้ด้วยนะคุณนักรบเอาใส่หน้าอกเลยครับหนีบไปเลยกระเป๋าเสื้อก็ได้คนไหนเขียนเสื้อมาครับห้อง4ครับแล้วคุณจะเช็คชื่อกันไหมผมเขียนเสื้อโอเคครับฮัลโหลได้ยังได้แล้วได้เดี๋ยวเอาไปไว้ในนี้อีพอร์ตคุณโน้นเหรอคุณรู้ไหมกูไม่ใจเย็นฟิสิกส์วันนี้ใครลาบ้างนะวันนี้อีกคนเดียวมีหลักฐานการลาไหมมีการลาไหมมีหลักฐานการลาไหมโอเคมีชานนท์คนเดียวนะที่ป่วยอันนี้อะไรวะอันนี้คือส่งย้อนหลังที่โอเครับทราบเดี๋ยวคุณดูชื่อวิชาก่อนนะ Good afternoon everyone welcome to SCI33206 First we will check attendance เลขที่1ครับคนที่ครับกินครูทิพย์ครับครูทิพย์ทาราครับที่นั่งอยู่ตรงนี้เลยนะครับทารากัตตกรครับวันนี้มีเสื้อให้ผมเขียนนะครับถ้ามีเสื้อให้ผมเขียนนี่ให้ผมเขียนได้เลยนะครับศิลวิทย์ครับศิลวิทย์สุขีครับใครไม่พรีเซนต์วันนี้0เลยนะวันนี้ใครไม่พรีเซนต์ได้คะแนนได้คะแนนเก็บ0นะครับ20คะแนน0เต็ม20นะครับเราวิพลครับเราวิพลคุณหมอนะครับทีมสิงห์ครับต่อไปทีมสิงห์ครับเต็มภูมิครับดีมากครับทีทัศน์ครับเลขที่9ทีทัศน์อยู่ไหมครับไปเอาเพื่อนเข้ามาครับไม่งั้นไม่สามารถเช็คชื่อให้ได้นะครับพิชานันท์ครับพิชานันท์วันนี้มีคนเขียนเสื้อให้เยอะไหมครับดีครับทัศน์ภาคินครับศิลวิทย์ภูขีครับศิลวิทย์ปกตินั่งอยู่ตรงนั้นปกติจะนั่งอยู่ตรงนี้นะครับวันนี้เข้าไปไหนครับศิลวิทย์ภูขีที่ทัศน์มาครับที่ทัศน์ศิลวิทย์ภูขีอยู่ไหนครับได้ครับศิลวิทย์ภูขีมาครับทีครับทีกิติวรพัฒน์นะครับมาครับไม่เหมือนโดยตรงแม่งไม่ใช่ธนวิทย์ครับธนวิทย์ครับสวัสดีครับรัตนะครับรัตนะวันนี้ไม่ถอดเสื้อหรอครับรัตนะศิวกรครับคุณหมออยู่ไหนครับศิวกรอยู่ไหนครับยังไม่สามารถเช็คชื่อให้ได้นะครับนัทพลสิริถาวรครับดีครับชยุทธพลครับคุณกรครับคุณกรอยู่ไหนครับกรครับกรเดี๋ยววันนี้กรนำเสนอกลุ่มแรกเลยนะครับดีครับเตรียมไฟล์ให้พร้อมเลยนะครับใครจะนำเสนอวันนี้นะครับเรามีเวลาจำกัดนะครับอภิโชติครับอภิโชติ ชานนท์ครับชานนท์ครับชานนท์เดี๋ยวเวลาได้เลยเดี๋ยวขออนุญาตเช็คหลักฐานก่อนนะครับนะครับชัดเจนนะครับว่า Photoshop นะครับ
โอ้อะไรวะเนี่ยเมื่อกี้ไม่มีอะไรเขียนว่าอะไรนะอาจารย์ลาเขียนว่าอะไรครับ Live due to sickness กมลสิทธิ์
กมลสิทธิ์ครับกมลสิทธิ์
อยู่ไหมครับอยู่ใช่แล้ว
สุภรัตน์ครับสุภรัตน์นัทพลเอครับคุยใหญ่อยู่ไหนครับพาวครับพาว
เอาจริงมันต้องเป็นนัทพลเอ็นนะเว้ยนัทพล
นัทดลครับอริยวุฒิครับบริษัทครับและวัสันตพัฒน์นะครับ
วันนี้ไม่เป็นเล่นบ้านนะ
วันนี้ใครนำเสนอนะครับก็สามารถเตรียมไฟล์ได้เลยนะครับแล้วก็วันนี้เรามีเวลาอย่างจำกัดนะครับขอให้ทุกกลุ่มใช้เวลาอย่างมีคุณค่านะครับจะเริ่มที่กลุ่มของทาราครับ
กูได้เช็คชื่อแล้วเว้ยกูได้เช็คชื่อแล้วเว้ย
เดี๋ยวเราก็ได้เช็คชื่อไซโก้เดี๋ยวส่วนนี้เข้าไปใน
มึงส่งไปไหมไม่เป็น
คนนี้มันเป็นด้วย
export all ไป PDF ไปแล้วก็เดี๋ยวมึงเลือกลายให้ถูกนี่
นะครับไซโก้มีเช็ค attendance มีดูว่า
มันเป็นกวนนี่ก่อน
เรื่องของ
แบบนี้เลยใช่ไหม
คิวการนำเสนอนะครับที่เพื่อนเขาแจ้งผมมานะครับกลุ่มแรกจะเป็นกลุ่มของทารานะครับหลังจากนั้นจะเป็นของวสันตพัฒน์นะครับแล้วก็จะเป็นของนัทดลนะครับแล้วก็กลุ่มสุดท้ายจะเป็นของอริยวุฒินะครับ
เข้าโคมเลยโคมอาจารย์พร้อมแล้วครับอาจารย์ไม่เขียนตรงนี่มันวางนี้ก็ได้วางนี่ดีกว่าเดี๋ยวทำของเขาพังมาเร็วที่มา1 2 3 4 5อัดมาแจ๊บมาโอเคครับใครเริ่มก่อนทีป่ะใช่ไหมใครหนึ่งแจ๊บ1เดี๋ยวเรามึงเปิดเลยก็ได้เพราะว่าไมค์ขี้เกียจยื่นให้มันลำบาก
ไม่ต้องให้ไมค์นี้มา
ตัวนี้มันอันนี้มันตัวนี่คือเรคคอร์ดใช่แต่ไมค์อยู่นี่ซึ่งอันเนี้ยไว้กับเสื้อเราตลอดก็ได้
ก็คือพูดแล้วมันก็เขียวตลอดเลยก็ฟ้าตลอดตัวนึงก็เขียวตลอดตัวนึงก็ฟ้าตลอด
ตัวนี้ต้องย้ายระหว่างเพื่อนไหมครับอ๋อโอเคต้องอันนี้ต้องย้ายแล้วเขาว่าถ้ามึงพูดนี้ก็อยู่กับมึงแล้วก็ย้าย
กูเปิด 3.5 kilograms of uranium whereas producing the same amount of energy using fossil fuel would require over 600,000 kilograms
กูเปิดยังไงดีวะก็ฮัลโหล
วันนี้เราจะมาคุยกันเรื่องแลบเป็น10แลบเกี่ยวกับนิวเคลียร์พาวเวอร์แพลนว่าจะทำงานยังไง
แต่เป็นภาษาอังกฤษ
โอเคเริ่มเลย Hello everyone. So today we're going to talk about the simulation of a nuclear power plant. Our numbers are I'm number 7, and I'm going to start us off with what is nuclear energy. So nuclear energy is a very broad term, and
something that will take a lot more to explain. But in this case, we're going to be talking about nuclear energy that is usable to us as humans. Now, obviously, we don't use nuclear energy in our households to power our lights, the TV, and the air conditioner, but we use electricity instead. So, with a nuclear power plant, we use this nuclear energy and transfer it into electric energy that we can use. Now, this process is done like just the same as any other factory or power plant that's not necessarily nuclear, which is by either using like coal, oil, or gas to heat up water, which then produces steam, which then drives a turbine, and which then turns that energy into electricity. Now, the only difference is that in nuclear power plants, we don't use fossil fuels, we use nuclear fission. What is nuclear fission? Yeah. Yep. Okay. So, what is nuclear fission? Nuclear fission is when a neutron hits an atom. In this case, or in most power plants, is uranium-235, which then is when the neutron is shot into the atom, it's the nucleus absorbs the neutron, which then becomes unstable and splits into two smaller nucleus, some energy, and a few more neutrons. These nucleus are the byproducts that can keep on in chain reaction, as well as the neutrons. These neutrons can split further, resulting in a chain reaction. So one neutron hits, splits into multiple neutrons. These neutrons hit even more atoms. And then there's also the energy that is released, which is then used into generating heat, which then turns into electricity. Now, nuclear power stations are designed to control this chain reaction so that it doesn't stop or even go way out of hand. They control so that it doesn't go too much, so that it doesn't explode, or go too little, and you have to restart the reaction. And another benefit of using nuclear power plants is that there's no burning fossil fuels like in the other examples with the coal or oil. There's no CO2 released at all, except during the other processes not involving nuclear fission, like transportation and mining for uranium-235. Because uranium-235 here, by the way, is used because it's one of the more accessible and easy to use atoms. Next is nuclear reactor.
Hello. I am no, ตรงไหนวะ Hello. Yeah, I'm Tikatiwapat, number 33. Okay, so the reactor core is where the nuclear fission reaction occurs. The reactor core is where the nuclear fission reaction occurs. Within the core, metal tubes containing pellets of uranium-235 are stored. This is what powers the pressurized water reactor. Now, underwater reactors often produce a blue glow. This is called Cherenkov radiation, which is the type of electromagnetic radiation that occurs when a charged particle travels exceeding phase velocity within a dielectric medium, as seen here. Okay, now one of the advantages of nuclear reactors is that they are incredibly fuel efficient. Running this type of reactor for 1 hour requires around 3.5 kilograms of uranium, whereas producing the same amount of energy using fossil fuel would require over 600,000 kilograms of coal. Now, next is the control rods. Control rods work by absorbing neutrons and stopping the splitting of uranium nuclei. The further the control rods are descended into the core, the lesser nuclei are split, and this helps control the temperature of the core and helps control the reaction within. Okay. Now, these rods are held in place with electromagnets, and in case of a power cut, they would immediately fall into the reactor core, stopping the nuclear reaction within.
Okay. ครับแป๊บนึงปั๊บ So let's now talk about coolant. Coolant in a nuclear reactor is a substance used to transfer heat away from the reactor core to generate electricity for other purpose. It helps to regulate the temperature from the reactor core and prevent it from overheating. It also slows down the neutrons in the reactor core, which makes the fission reaction more effective. Common coolants include water, heavy water, liquid sodium, and gas, depending on the type of reactor design. หน้าต่อไปเลย And the next one is the pressure vessel. A pressure vessel is in a nuclear reactor is a robust container designed to contain the reactor's nuclear fuel, coolant, and other components at high temperature and pressure. It serves as a crucial barrier to prevent the release of radioactive material to the environment. The pressure vessel must withstand extreme conditions and is typically made of high-strength steel or other materials capable of withstanding the harsh environment inside the reactor core.
So from number 11. So to move these coolants around, obviously you have to have a pump. The coolant pump moves the coolant around the primary circuit, which run between the reactor core and the steam generator. The coolant enters the pressure vessel at 290 degrees Celsius when the reactor starts up. They heat the coolant to the correct temperature. The pumps heat the coolant to the correct temperature before operation begins. Now, these are very powerful pumps. They can drain an Olympic-sized stadium pool within 80 seconds. Now, next up is the pressurizer. When the coolant becomes very hot, reaching around 325 degrees Celsius, we would normally expect it to evaporate into steam. However, we don't really want it to do that in the nuclear reactor, as that would cause multiple problems. So, using the pressurizer, the coolant is then kept at a very high temperature, forcing it to stay in a liquid form. That is why it is called pressurizer. Pressurized water reactor, excuse me. And the pressure within these tubes are around equivalent to a mile under the sea.
So next I will discuss two of the most important and very genuine innovations that leads to a proper functioning of a nuclear reactors. The first part is called the steam generators. As previously discussed, we know that in a typical pressurized water reactor, there exists
two systems of flows in terms of the coolant. First, the coolant will flows to the primary circuit, meaning that the coolant will flows directly to the reactor core, where the fission reactions of uranium-235 and in another circuit it is called the secondary circuit, meaning that the coolant will not flow through the uranium core, and instead it would flow through this very integral part of every nuclear power plant, being called the steam generators. The steam generators in its essence are there to produce steam, of course, the name it suggests for itself. However, you might wonder that the coolant that comes from the primary circuit will it produce steam because it is pressurized in the same manner that the Earth's core is pressurized by all the weights of the continents. It will not turn into steam. And yes, you are correct. The coolant that flows through the secondary circuit will be turned to steam, and it will be the factors which contribute to the power productions of any nuclear power plant. The coolant themselves are, of course, a very integral part to any nuclear reactor, and as a result, I would like to use this opportunity to discuss further with regards to the engineering marvels behind the coolant. I would like to talk about the Westinghouse steam. Steam generators. Now, this is one of the most common steam generators that is used in, let's say, almost every nuclear power plant that exists on this planet. And there are multiple reasons to which I would like to discuss it further today. But at first, it's very beautiful. From the schematics, right? I'm not an engineer. I want to study science, but I'll try my best. So you see that there is two systems of flows in regards to coolant. The first system is the primary circuit, which flows directly from the reactor core, and another system is lead into this pipe right here, being called the secondary circuit because it isn't pressurized and it's there to produce steam to power the turbine. This schematics is it's the schematics for the Westinghouse steam generator, which is produced by Westinghouse Electrics, and one of these systems costs around 10 Mercedes-Benz. To be precise with my comparisons, and I would like to show the real constructions of the systems, and from this picture we can see that one advantage of the Westinghouse steam generator is that it's like a Lego pieces. You see, this compact system and being installed in there very easy to install and produce very high in terms of efficiency as well. And after this, it also took like only a few times and only a few months to complete the installations, which is why the Westinghouse steam generator is kind of monopolized the steam generator markets anywhere when the nuclear reactor is being constructed. The Westinghouse model is, of course, regularly used. After the steam generators, I would like to discuss another important part that is required for the proper functions of a nuclear reactor. Not just a nuclear reactor, but a typical power plant also requires a very good turbine. So what do turbines do? So we know that the coolant from the secondary circuit are converted into steam, and those steam are there to propel the turbine. The turbine will lead to the propellant of the generators that produce electrical energy for appliances and for urban applications. However, the turbine itself is very special in the nuclear reactor because because the turbine needs to be able to be acid resistant. Previously, when talking about coolant, I would like to discuss further that the most common type of coolant that is used in nuclear reactor is called sodium borate-based coolant, or it produces boric acid. So its steam is also very acidic. So meaning that the turbines that are employed in a nuclear reactor must be very resistant to chemical retardations. And I would like to show an examples of the Arable turbines. This turbine is produced by General Electric companies, and the size of this turbine is approximately 30 meters in length. In comparison to okay, let me show the real schematics for these turbines, and it's much more complicated and intricate than the turbine that is commonly seen in a typical power plants. And one major major differences is also its ability to be very resistant to chemicals, as I discussed earlier, and also be of high efficiency in producing the lowest amount of friction possible. Next, we'll be discussing the electrical generators.
So I am number 18. So inside the generator, there will be a production of the electricity by the movement of spinning turbines. So the turbine will spin the magnet inside a coil of wire to produce the electricity. And this type of electricity will be an alternating current. The current will then be leave the generator and will be spread to use across the country. Next is condenser. So after the electricity leaves the turbine, leaves the generator, the steam will leave will cool down and condense into water, and then the water will then flow into the steam generator again to produce the steam. The water in the cycle will be reused again and again.
Hello. All right. Now that the theory part is over, let's talk about music. All right. Now that the theory part is over, let's talk about the simulation part. Now this one is quite the simulation for how the power plant works, but this got simplified a bit to just only three main parts. First is the pump, open the coolant part. Second is the reactor core part, and the third one is steam generator. Let me just show you how it works, and if you come to this website, you can go back and look at each part again. And let me hide that. So first, we gonna open the coolant pump to get the water to get to the temperature it needs to be. Yeah, coolant. Yeah, so as you can see, we speed up the process so that the coolant has the right temperature of 220. And now we raise the control rod up not that far.
That far,
Yeah.
The reactor would power cut immediately.
Yeah.
Because in a typical reactor, accidents are prevented at a very high level because the cost of one major incident is of course very high. No one wants another 3 Mile Island or Chernobyl.
All right. So now that we have seen this, so let me talk while this is stable, because as you can see, the demand is fluctuating, and throughout the day we have to balance how much power we have to output. So first, let's talk about what we did with the reactor core. What we did is we raised the control rod position to get up and allow more things. All right. When you raise the control rod, you allow more nuclear reaction to happen, and thus you will make more energy, making the coolant hotter. And now, but when you release more steam, when you release more steam, as you can see, the coolant pump
will have less energy, and that is because when you release steam, you give off energy, so making the coolant colder. And as you can see here, we already at 5, and now the demand is fluctuating downward. Oh, be careful. This shouldn't happen in real life because if something like that happens, a lot of people are gonna be in danger. And now the demand steadily go up. Don't forget to keep your eyes on the temperature because, as I said, if it fluctuates too much, it can turn down the entire reactor. Alright, the demand is going up again, and now the temperature is quite low. So we have to raise the control rod to allow more reaction to happen. This is much easier to do in computer because you have the keyboard to just control more precisely, and precision is what we need to operate the nuclear reactor. Right. Now it's almost over for a day. Just a few more hours. As you can see, there will be the warning about whether the demand is going up or down, or if we expend too much or too little power for demand. And this is the end of one day as a reactor engineer. Thank you for listening and watching our presentation.
Thank you.
Yes?
What is the downside or the shortcoming when you produce electricity above the level the people need?
Overproduction cost เปลืองตังค์คือไอ้การไฟฟ้าประเทศเราจริงๆมัน overproduction อยู่นะตอนเนี้ย Hello. In terms of overproduction of energy, from my point of view, uranium is a resource that is used in its productions, and mining of uranium is very costly. It involves quite a lot of carbon emission in the process. So in my view, one of the most disadvantages in terms of overproduction is that nowadays nuclear reactors are safe enough such that overproduction doesn't lead to a meltdown like those that happen at 3 Mile Island. However, overproductions may indirectly contribute to the problems that nuclear reactors are designed to solve, which is through the reductions in carbon emissions, and it shouldn't be done. In real life, mathematical models are employed to calculate the mean amount of energy that a specific city or specific areas use to prevent over and underproduction.
Thank you very much. Let's talk about the next presentation. Yeah, come on.
Whoa!
What the fuck? กูเห็นอะไรอยู่เฮ้ยชัดดาวเลยเหรอเฮ้ยเส้นเหรอ
เฮ้ยเหลือ
ใช่operating system หรือว่าเราจิ้มไปเลยเว้ย
ได้ไม่ใช่ต้องมายืนด้วยกัน
ไม่สุดแรงนี่แผ่นไหมเดี๋ยวจิ้มไปแผ่นคือ
ได้ไอแพดมึงก็ได้แล้วก็เปิดโมเดลนั้นเปิดโมเดลเราเวลาไม่พอ ตั้งใจมากเลย
เดี๋ยวกูจะพูด
เวลาคนเขาเนี่ยเจ๊ป่ะ
พูดสาม
เจ๊มาดิ
เซตมึงเซต กินมาดิ
จิ้ม
ใครเริ่มก่อนนะ ใครเริ่มก่อนเราตามที่คุยกันมานะ ใครเริ่มก่อนนะ ตามที่คุยกันมา ใครพูดเปิดนะ โอเค สุภราชพูดเปิดครับ
Yo guys, follow me online.
จะจากยาวนะทุกคน วันนี้ก็เข้าสุดท้ายครับ ผมก็รู้สึกว่าค่ำนี้ผมมีความสุขที่สุดครับกับดร.บำรุงครับ ขอบคุณมากครับดร.บำรุง
สวัสดีครับวันนี้เราจะมาพรีเซนต์เรื่อง
ข้อสุดท้ายบอกเลยดร.บำรุง
ผมต้องขอบคุณอาจารย์บำรุงนะครับที่สอนพวกเรามาผมรู้สึกปลาบปลื้มใจมากๆนะครับที่
ดร.บำรุงครับ
นี่ Follow me on IG.
ไว้ก่อนครับไว้ก่อนครับ
ไว้ก่อนครับ
Good afternoon, everybody. My name is Suraj Yodgao.
Good afternoon, everybody. My name is Suraj Yodgao. Today we will be presenting about and atom. So first we got protons, we got neutrons, we got electrons.
ไม่เหน็บเสื้อไม่พูดต่อเลยเดี๋ยว
Proton is the positive part of the atom. Neutron have neutral property, and electron negative property. เสร็จแล้ว
เฮ้ยไม่เราเตรียมมันเป็นวันนะเว้ยเราเตรียมเป็นวันเลยนะเว้ย
So we will start at the symbol one, and we can see that if I add proton, neutron. So proton refer to the orange one, and neutron will be referred to the gray one, and the last one is electron will be referred to the blue one. So we can see that if I add one proton, it will be hydrogen, and if I add more helium, add more it will be lithium, and add more it will be beryllium. So we can see that the element will be changed due to the number of the protons that I add. So if I add neutrons here, so we can see that the number of the mass number will be changed. That if I add two more, it will be changed. That it will add the number of mass, and if I add more, it will be 6. Add more, it will be 7. So we can see that the neutrons will be will increase the number of the mass number of lithium, and we arrive at the last one, which is the electrons. So if I add one electron, the ion will be decreased, and at 1 it will decrease more, and if I add 3 it will be 0. So we can conclude that the electron will be we have the effect to the number of ion, and it will decrease the number of the lithium that we have here as the full protons.
1 2 3 4 5 6 7เจ๊ครับเจ๊ใครพูดต่อ Okay, everyone. So today I'm going to be talking about the protons. Tanawit Satarosip, number 14, room 604. Now, the protons here is a stable subatomic particles, and as you can see here, it's in the orange. And as you can see, it's as you add more of it to the circle here. Sorry. on the iPad here, if I move it here one, you can see the element is first in the table, it's hydrogen. If I add more, it's going to be helium. Add one more, it's going to be the lithium. Next, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So what you can notice here is that it's all from the elements table, as you can see here. So we can conclude that from my presentation is that if you add more protons, like here we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's gonna be each proton is gonna be as the same as the element. So like first it's hydrogen, helium, like that. So if you add more and more, it's gonna be for all from the element, the periodic table, like that. So as my friend's gonna tell you next about what will happen with the neutron and electron next. So welcome Mr. Sivakorn, myself too. Sivakorn, please say next part, please.
Hello. Okay. So my name is Sivakar, M604 number 17. So let's talk next about the net charge of after we add the subatomic particles, protons, neutrons, and electrons. So first of all, protons have positive charge. So if we add one proton into the middle, we will see that the net charge is now positive 1, which is the result of protons, because protons has plus 1 net charge, while neutrons, it has no charge. So if I add one neutron into the middle, you will see that the net charge still remains the same at positive 1, because neutron doesn't have any charge no matter how much I added neutrons. I add 3 neutrons, but still the net charge is still positive 1. While the electrons have the charge of negative 1, so if I add 1 electron into the middle, so let's add 2 electrons to be simple. The net charge will be negative 1, because we have 1 proton that is positive 1 and 2 electrons that is negative 2. Accumulated, we have the net charge of negative 1. And this is the net charge of after adding some atomic particles into the nucleus. Next.
Okay, hello. So my name is Mr. Kitchip Onsong, number 2, room 604. And now I'm going to be presenting about the mass number. Okay, so first let's try add 1 proton. As you can see, if we add 1 proton, the mass number will be 1. And then we add another proton, then it will be 2. And if we add 1 neutron, the mass number will be 3. This is because this number right here is in the unit of AMU, and 1 AMU is equal to 1.67 times 10 to the power of minus 27 kilograms. And the protons and neutron is also at the similar weight of 1.67 times 10 to the power of minus 27 kilograms. So if we add 1 proton, the mass number will be up by 1, and if we add 1 neutron, the mass number will also be added by 1. So if we try adding more electrons, as you can see, if we add more electrons, the mass number will stay still. This is because electron is 1,835 times lighter than proton and neutron. The electron weighs at 9.109 times 10 to the power of minus 31 kilograms. So If we add more electrons, the mass number wouldn't change. But if we add protons or neutrons, the mass number will be changed by 1. So for example, if we add 7 protons and 4 neutrons, the mass number will be 11. And if we add more neutrons, it will be 12, and so on and so forth. Next is Sem.
Oh, okay, so my name is Kamosit Tirasitikun from 604 number 23. So my part is gonna tell the method to identify is that element is gonna be stable or unstable. So first of all, let's put proton first. I'm gonna put 3. I'm gonna put 3 proton, which is lithium. Moreover, I'm gonna put neutron. It can be seen that it is unstable. So why it is stable or unstable? It is because of the neutron over proton ratio, or also known as the nuclear ratio. So if the ratio of neutron over proton or proton over neutron is a bit too large, it can be considered as unstable. For example, this is 3 proton, right? If I put like 6 neutron, is gonna be unstable because the ratio between proton and neutron is quite far. But if I remove to be 3 proton and 3 neutron respectively, the ratio will be stable. Also, if it's too many proton or too few proton, it can make the element to be radioactive, which can be called unstable. And also, the element which the atomic number is more than 83 would also be considered as an unstable element, because the repulsive force in its nucleus is going to be larger than other elements that have the atomic number lower than 83. So here is my part for identifying which element is stable or unstable. Alright, okay. So I'm here to sum everything that my friends have talked about. So first of all, I'm checkpoint number 19. Here. So to build an atom, first of all we have to have both protons and neutrons. If you were able to if you're able to notice, most of the atoms are mostly dependent on the number of protons, right? So if you see here, if I just insert a whole lot of neutrons in here, the element will be still hydrogen, right? But if I were to change the number of protons, the element will also change. But it's from the matter that it will be unstable or stable, it's not dependent on the protons. It's mostly dependent on maybe the mass ratio or how the orbit is arranged, maybe the SPF orbit. But enough of that. Let's say what makes the element unstable. So it's mostly usually related to each element being an isotope. Isotope is, as you know, that many elements have the same number of protons. Since if we add different number of protons, the element change, right? But let's say we have hydrogen here, right? And electron is here, right? And this one, if we were to change its mass, which is hydrogen isotope, this one is mass number 3, and this one is tritium, right? And this one is deuterium, which it is in fact still a hydrogen, but it's a different kind of hydrogen. So this is an isotope for hydrogen, and there's a graph for it. If there are, like, let's say there are 3 variants of hydrogen, we can plot it out and we can find like how these kind of elements are being found in nature. But the most, if you would be known, this one is the most prevalent in one. But these one, deuteriums and tritiums, are mostly prevalent in the nuclear fission in the sun, right? And other than being in hydrogen, other elements also tend to have their own isotopes, right? It's not only limited to hydrogen. It's every element. Just that element must have the same numbers of protons. As the saying goes, like iso is same, right? And tope is protons. So the same number of protons, but different numbers of mass. And that's why one variant of this element is stable, but other, like such as deuterium and tritium, it's unstable because it's due to different mass numbers. So yeah, it also depends on many different key factors other than having different elements. So, since sometimes the same element can having different stability state. And I'm going to sum about this symbol. So here we got a symbol. As I said, there's proton is dependent from changing the element, right? And this one is the atomic mass, and this one is atomic number. Atomic number is the number of protons in the atoms, while atomic mass is like neutron plus neutron plus proton. But we didn't count in electron because since the mass is so minute, and so it doesn't seem to matter if we add it to like a very minute scale. So we only count both of protons and neutrons. And this one is ions. Since this one is 0, that means the ions is stabilized, right? There's no charge. But if we were to put more electron, which is the negative charge of the element, the ions will change to -2. So which one? Protons and electrons is dependent for changing the charge of the element. Yeah, so that's pretty much it for our group. Thank you very much.
Talking about the crowd presentation.
Oh, what again?
Oh, the cloud shape.
So in your group,
So if I were to explain about the cloud, so the cloud derived from a theory that electron can exist anywhere between the nucleus. So it's not usually an orbit like this, but sometimes we are not definite where the electron really exists. So this one is the center of the mass, right? And everything revolves around this one, but we're not sure if we to put the atomic particles as electrons. We are not sure where it resides, so that's where the theory of cloud electron derives from. Yeah, but usually it's not different since the electron can revolve around here, but we just don't know where it is. So that's why the cloud theory comes in.
Okay, thank you very much. Let's move on to the next. Oh shit.
ไม่ไหนไม่ลองไหมนะไอโยขำอะไรขำอะไรขำ
Oh shit!
ขโมย
Oh,
ขโมย
Black activity. Keen is black activity. Black. Keen is black. Hello.
ไม่ได้สอนอันแป้นหรือต้องใครพูดก่อนให้อาร์มพูดก่อนจับเบาๆนะเดี๋ยวมันติดต้องติดเหรอไม่ต้องติดเหรอต้องติดทำไมต้องติดใช่ไหม
ไม่ได้ถือแล้วพอเราพูดเสร็จปุ๊บไม่แล้วพอพูดเสร็จปุ๊บก็ค่อยเปลี่ยนคน
ถืออันนี้ตอนพูดด้วยใช่ถือทุกอย่าง
โดนปุ่มมาไหนไม่ได้ใช่ไหมอาจารย์อย่าไปโดนปุ่มนะใช่ไหมอุ้ย
เราของกูเลย
ไอภูมิมึงต้องทำปะทำไปหรอกูพูดปะ so okay hello my name is Ratana Wongwatana School I'm sorry my name is Ratana Wongwatana School my number is 16 from 604 so I gotta introduce that the nuclear physics simulation it's being held to allow the user to understand and stimulate about the nuclear fission. The website itself it helps us change and control such as the size and the shape of nuclei or the neutron speed or factors that affect the fission process. Which we as a user can observe the process throughout the whole actions. Which with this one we're gonna do about the nuclear fission on one nucleus. Nuclear fission is a process which nucleus of an atom splits into two or more smaller nuclei. Among the release of energy and neutrons, this process of nuclear fission typically occurs on heavy elements such as uranium minus 225, uranium 225, and plutonium 239 when bombarded by neutrons, right? During the fissions, neutrons collide with nucleus from heavy atoms that I showed you earlier, which it become highly unstable. เปลี่ยนอาจารย์
อุปกรณ์เขาเยอะเลย
ต้องไปเซฟอ่ะ
อยู่วะ Hello. So as you can see in the picture, I'll show you the process of this fission. The nucleus then split into two more smaller nuclei called fission fragment, along with several neutrons. These neutrons can go initiate further fission reaction, creating a chain reaction. So as long as I press the button here, releasing the neutrons into the 235 uranium, made it 236 and made it separate into the daughter nuclei, as you can see. And the graph, again, let's reset and do it again.
Yep, and the graph also split into two. So the energy released during the nuclear fission is enormous, and it is the energy that is harnessed in nuclear power plants to generate electricity. In addition to energy, fission also produces radioactive byproducts which must be carefully managed to prevent environmental contamination and health risks. So I'll show you the last time. Step 1, releasing the neutron into the uranium and it split, creating the chain reaction and made the energy enormous. Yeah. ต่อไปเป็นดาราแล้ว
คือในกองนี้มีพวกนี้เหมือนกัน
ต้องเข้ามาอยู่ AA ฮะใครอ่ะ AA ใช่ AA บัส
Yes sir ไม่ต้องกดแรงขนาดนั้นกดแค่นี้เนี่ย
Okay, so the next part I'm going to be talking about is chain reaction. And what I'm going to be talking about is chain reaction in general. So a chain reaction in nuclear physics is referred to as self-sustaining process where a series of nuclear reactions leads to continuous release of energy. And in the context of nuclear fission, which is the splitting of atomic model or a nuclei, a chain reaction occurs when the neutrons release during one fission, like the last one we have told you. And here's a event trigger further fission reaction in nearby nuclei, and it's releasing more neutrons and continuing the process. So understanding and controlling chain reactions is crucial, and it is safe and is also efficient operation for nuclear reactors. And it's going to be the next one. So I'm going to let Nobel explain how the chain reaction is occur. So my name is Natadon Karise. Now my number is 27.
I'm just saying number 21.
เราต้องดูแลดาราหน่อยเปิดแน่นอน Hello. Okay. My name is Vishanan Srikan, number 10, 604. I will talk next about the outcome in general, and also I will take a look to this website. So this cascade of this This cascade of reactions can occur rapidly, resulting in a significant release of energy in controlled nuclear reactions, such as those in nuclear power. Carefully managed to ensure a process at the control rate, generating heat that can be used to produce electricity. However, in controlled situations such as nuclear weapons or accidents, and uncontrolled chain reactions can lead to catastrophic consequences due to the rapid release of energy. So next I will show you both the uranium-235 and the uranium-238 and the reaction to the neutrons. So if I press the button, if it hits the uranium-238, it will change into the 239. But if the neutron passes through and hit uranium-235, it will increase the energy and also explode to the daughter nuclei and the neutron itself too. And I will reset it to make sure that it will be this one. Yeah, as you can see, if the neutron that explodes from the uranium-235 hit another uranium-235, it will also be the chain reaction or the topic that I talked about. But like I said, if it hits the uranium-238, it will be 239. So that is all about the chain reaction, and I will and Jen will be talking about the nuclear reaction. Nuclear reactor. Yes.
So my name is Jeng Titasakrin, number 9. Okay, so let's take a look at what really is a nuclear reactor. A nuclear reactor is a device that harnesses the energy released during the process called nuclear fission in order to generate electricity. It operates by controlling a sustained chain reaction of fission reaction within the control environment. And let's take a look at how it works. The first factor, fuel. The reactor core contains fuel rods typically made of enriched uranium and plutonium. These fuel rods are arranged in a way to facilitate the chain reaction. The next factor is control rods. The control rods made of materials like boron or cadmium are inserted or withdrawn from the core to control the rate of reaction. By adjusting the position of these control rods, operator can regulate the number of neutrons available to sustain the reaction. And also the next is coolant. A coolant such as gas, such as water, gas, or liquid metal circulate through the reactors during the fission process. This heated coolant then passes through a heat exchanger to produce steam. The next is also, as I have mentioned, it will be the steam generation, in which the steam produced by the heat exchanger that drive turbines which are connected to other of the generators, converting the kinetic energy into electrical energy. And also what is next is the safety system, which is a quite important factor. Nuclear reactors are equipped with various safety systems and safety measures to prevent accidents and mitigate their consequences and risks. This includes emergency shutdown mechanisms, containment structures, and backup power. Overall, nuclear reactors provide a reliable and efficient source of electricity with minimal greenhouse effects and also prevent challenges such as radioactive waste management and the risk of safe accidents, which require more strictly measure and regulation. So it will be from Brampton.
Hello, my name is Fatam uh, 605 60522. So I will show you how nuclear reactor works. So if we hit the button, fire neutron, the power of it will yeah. You say ใหม่ได้ปะ Okay, so if we put fire neutron button, the output, the power output will gain first, and will gain first, and then as the time pass, the energy produced will gain respectively. And as you can see that first in table, it will be, this one will be green, and after as the time pass, it will turn red. Thank you for listening.
Okay, so overall, after pressing the iron on, the uranium-235 will explode on fire and also change to the red one. And as you can see, the power output will be gained as said. And after the explosion, energy will be produced, and the heat will also change. Change too. So that is all the nuclear reactor.
Temperature change.
Regarding to the uranium exploding. Yeah. And then so that is all about our presentation about fission, chain reaction, and nuclear reactor. Thank you.
Thank you for listening.
เราเคลียร์เราเคลียร์ของเราอีสเตย์เรียบร้อย
there any further group who would like to present here? How much time left do we have? 38 minutes. 38 minutes. Holy shit, this is fucking small, bro.
สำหรับคนที่ไม่ได้เรียนแล้วเคลียร์บริเวณตัวเองก่อนว่าเคลียร์ขยะจะได้ง่ายต่อการเคลียร์ก่อนจบขอบคุณครับเคลียร์ห้องครับ
เราไม่เราจะเคลียร์ของตัวเองให้โลกก่อนนะ
ไม่ใครมีถังขยะใหญ่สุดไหม
อยากเขียนไปงานอันนี้ให้น้องสักหน่อยไหมคุณก็พูดเลยครับเปิดไอแพดเอาส่งมาจากที่เจ๋งส่งมาจากจะเอาแผ่นเขาที่ตามเร็ว
ขยะไม่เยอะชิบหายเลยคนที่บ้านอ่ะ
มึงรู้ตัวเหรอขยะเยอะ
วันสุดท้ายก็กูอยู่ได้มาทั้งปีแล้วเท่าไหร่กูไม่อยากให้ลูกน้องต้องมาเจอเลยลูกน้องก็สะอาดกูไม่สะอาด
เดี๋ยวเอาถุงดำเดินก่อนเลยไหมถุงแม่มีอย่างเดินเลยมาไปไอ้ที่คุณทำมันใหม่ทิ้งไปยังส่งไปยังรอยแล้วก็ไม่โอ้ยอันเก่าที่มึงทำอ่ะมันยังมีแบบอะไรว่าพระแก้วมันคู่บ้านคู่เมืองไทยอยู่เฮ้ยแกแบบโต๊ะนี่เป็นคุกกี้ด้วยมันสุกคือมันจะไปสุกคือมันจะไปบ้างมีข้อไหนที่ควรเลยโอ้มาเฮ้ยอาร์มมีใครอีกใบหนึ่งมีใครอีกใบหนึ่งโอ้ไปชื่อชัดมากเลยพิวแล้วก็เลื่อนไปล่างสุดพอสามเรื่องอ่ะที่สามไม่เป็นไรไม่พูดครับคำแรกเนี่ยเขาหรอมาใครได้พูดคนแรกไม่ชอบเลยไม่ชอบเลยโอเคกับใครบ้างบ้านเลยโอเคกูโอเคด้วยเดี๋ยวตลกฟังนะ
ไม่มีทางทีเดียว
ไม่เดี๋ยวยกขยะยังไงบ้านบอกว่าไม่มีคนเล่นนะ
ฮะก็ระวังนะเขาเรื่องนี้เดี๋ยว Okay, let's start our presentation on the structures of atom. And an atom basically is the fundamental building blocks of anything, of matter itself. It starts from atom right here. And the atoms, if you go deeper, it goes into a thing called subatomic particles, which includes these
three things right here: protons, neutrons, and electrons. And at the center of the atom lies the nucleus, which contains these two, called the protons and neutrons. And the electron orbits, as you can see by these dotted lines right here, are called electron shells, which contains electrons. We usually refer to them by levels using N as a symbol. Now, let's start on describing what these three actually are. Protons are subatomic particles that have a positive charge. Neutrons are subatomic particles that has a neutral charge, while electrons have a negative charge. Okay, let's select the metal element right here. Let's just go with
how many members are
blue. Okay, let's just randomly pick one element. Let's say it's hydrogen. In the hydrogen, there's two things that identify an element, which is its proton and its mass number. And in that, my friend will explain the rest.
Goodbye, teacher. Okay, so I'm going to explain about the charge. The charge is a sum of positive and negative charges in an object. Positive charges like proton contribute positively to the net charge, while negative charges such as electrons contribute negatively. For example, if I build a helium with two protons, you can see here on the net charge, it has two positive, and there's no electrons at all. So it's like currently like positive ions. But if you put one electron, it's still in a positive charge, but there's like one pair stable. To make it a neutral, you need to put in two electrons. And that's how you make a neutral atom. If you want to make it a negative ion, you need to include one more electrons or more. And for the sorry. Oh, and for the stable and unstable, in the context of stability, refers to the tendency of an atom to maintain a balanced and relatively low energy state. An atom is considered stable when its outer electron shell is full, following the octet rules, having 8 electrons. For example, lithium. Normally lithium was protons and 2 neutrons, but if you were to include one more neutrons or one less than normally, it would be unstable. But if you have 3, like it's same with like net charge, but it's applied with proton and neutrons. It needs to have like the equal amount of proton and neutron to become stable. But if the number of proton and neutron is not equal, it will be unstable.พูดที่ถามมันแล้วแต่มึงจะพูดเยอะพูด Mic. Okay, so my name is Aryo Davis and I'm number 28. So next up, I'm gonna talk about the periodic table. Let me just restart this real quick. Okay. So before I get into the detail of the periodic table, I just want to give you guys a normal knowledge about the periodic table. So basically, periodic table is just the table that lists all the elements in to this type of categories. And every element is categorized by its unique numbers of proton, known as the atomic numbers. And these atomic numbers define the elements identities. For instance, if I put one proton right here, it's going to be hydrogens, and if I put one more, it's going to be helium, and so on. And next up is the neutron, which are neutral particles, contribute to the element's atomic mass. Variation in neutron and numbers result in isotope atoms of the same elements with different masses. Isotopes share the same numbers of proton, but in different neutron. Like let's say if I put one proton, it's going to be hydrogen, and as you can see, the mass number is 1. But if I put 2 neutron, the mass number is going to go up. So the number of the neutron and protons combined. And and next up is the electron orbit. So the electrons orbit the nucleus and influence in elements' chemical behavior, changing the numbers of electron outs and atoms charge. Adding or removing electrons results in ions, but it doesn't change the fundamental identities of the elements. So let's see if I put one if I put 2 protons, it's gonna be helium, and if I put the electrons there, before I put the electron there. So as you can see here, the heliums will have 2 positive charge because the proton itself is actually a positive charge, and if I put 1 electron here, the electron itself is a negative charge, so it's going to subtract whatever the number of the net charge is. So in this case, it will be a positive 1. And so, as you can see, no matter how much electrons I put in, the elements is still going to be helium because the neutron doesn't change the identities or anything of the elements itself. It just changes the number of the charge. And next up, my friend is going to talk about the mass number.
Give me the mic.
Give me the mic. This here. Okay. Alright, so I am Purasak Sukjit, number 29 from 604. So I'm gonna talk about more about the mass number that Ariwood has presented before. Alright, this year. So firstly, we have to know what is the mass number first. So the mass number, it is the sum of the protons and neutrons in an atomic nucleus, and it's just a crucial factor in determining the element's properties. And now let's see how we can visualize them and manipulate this concept using the build and atom simulators. So as Ali would say before that proton itself is the positive, like if we put it here one. Proton and neutron itself will contain like 1 mass number. Like if you put 1 proton here, it will the mass number will be 1, and if I put more neutrons here, the mass number will become 2. Yep, just like this. And as we use this interactive simulator, you will notice that by adjusting the numbers of proton and neutron, we can see how mass number changes. And this hands-on experience enhances our understanding of the relationship between particle in an atom. Yep.
All done. Thank you very much.
Yes.